Welcome to Module 5 of this course. We're going to be discussing methods to evaluate the health effects of policies. This builds on some of the material from Module 2 on quasi-experimental methods, but we'll go into much more detail here. Specifically, here are the learning objectives we'll be covering. This course is going to equip you to understand why quasi-experimental designs are an important approach in policy evaluation. We're going to review quasi-experimental designs used in the field. We're going to compare and contrast the strengths and weaknesses of these designs, and we're going to discuss challenges encountered when evaluating policies using this design. And then finally, we're going to identify gaps in the current literature. So to achieve these objectives, this module is going to cover 4 different sections. In the first, I'm going to describe the motivations for quasi-experimental policy evaluations. Next, I'll provide an overview of quasi-experimental study designs. Third, I'll go about explaining how to choose an appropriate quasi-experimental study design. And then finally, I'll go over the gaps in the literature. So let's dive into the first section. Here's the overview for this particular section. I'm going to discuss challenges in designing policy evaluations. I'm going to go through an example of a causal diagram, or DAG, for a typical policy evaluation. I'm going to go through the definition of a quasi-experiment, and then I'll explain why such quasi-experimental designs are useful for studying social policies. Let's start off by imagining you're interested in understanding the effects of a particular social safety net policy on health among participants. So for those who aren't familiar with the term, social safety net policies are those that provide income or other resources to low-income families, and it's the focus of a lot of my own work. So to illustrate the challenges of answering this research question, I'm going to go through 4 study designs that you might think about using and discuss why they're problematic. So first, what if you decide to evaluate the policy by comparing health outcomes among participants versus non-participants? As an example, let's say we're interested in whether participation in the US WIC program affects breastfeeding rates. For those who are unfamiliar with this program, WIC is also known as the Special Supplemental Nutrition Assistance Program for Women, Infants, and Children, and it targets low-income pregnant and postpartum women and children under 5. What it does is it provides cash to purchase healthy foods, it provides nutrition and breastfeeding counseling, and it also provides free formula to those who don't breastfeed. Here are the findings from one study that compared breastfeeding practices by WIC participation status. So for every measure of breastfeeding, it found that WIC participants engage in breastfeeding less so than non-participants. So can we conclude from this that WIC itself does reduce breastfeeding? Even if you don't have a deep knowledge of the WIC program, I just told you that it serves an economically disadvantaged population. So we know WIC participants are more likely than non-participants to have lower income, and this often goes along with lower educational attainment. WIC participants are also less likely to be married, and they're more likely to be Black or Hispanic, which are historically marginalized groups in the US setting. So you could propose to just restrict the control group to people who look similar to WIC participants on these observed characteristics. And some of you may have heard of propensity scores or matching in earlier modules, and these methods can be used for this purpose, but you still might get biased estimates because WIC participants probably differ with respect to a lot of unobserved characteristics. So for example, they may be more likely than non-participants to have no access to paid family leave. There is no national paid leave policy in the US, so this means that women, and especially low-income women, often have to go to work soon after childbirth. And this might contribute to reduced breastfeeding rates among WIC participants. Alternately, the mere fact that WIC offers free formula might attract people who know that they can't or don't want to breastfeed for whatever reason. So there's selection into the program on the very outcome that we're interested in analyzing. All this is to say, if you're simply comparing participants and non-participants, you're very likely to get a biased answer and not the right answer that you're looking for. So let's go back to this list of other possible policy evaluation strategies. What about dropping the problematic idea of a control group altogether and instead just comparing safety net program participants before and after a given policy change? Here's an example of one policy evaluation that uses this technique. Let's say we're interested in finding out whether an unconditional cash payment increases breastfeeding. In this case, we have a US policy that actually did provide $1,200 to almost every adult in the US and $500 to almost every child. So our team actually did an analysis of this policy, and we found that breastfeeding duration increased by 17.5% over the baseline during this period when the cash benefit was issued. And you can see that represented by that vertical red line in the figure at about year 7. So then, after that, breastfeeding duration returned to baseline after a few months. So does this mean the policy was effective? And if you think about it, what else might explain this pattern? So what if I told you that the payments were received in early 2020 as part of stimulus checks issued by the US government in response to the COVID-19 pandemic? That's going to change your opinion of whether it was the policy that had this impact. And this is a particularly extreme example, but it does illustrate why policy evaluations that compare a single group before versus after a policy change are problematic. So first, they don't account for these kinds of simultaneous shocks or other policies that co-occurred with your policy of interest. In the case of this example, we know, of course, that in early 2020, there were workplace closures or remote work policies that might have forced or encouraged more people to stay at home with their babies, giving them more opportunity for breastfeeding. We also know that there were expansions to a lot of other safety net programs at the same time, and these may have increased income or access to health insurance, which we know are also determinants of breastfeeding. Or it might be that people reduced purchases of formula because they were worried about COVID-19 infection and didn't want to go to the grocery store. More generally, pre-post policy evaluations can be problematic because they don't account for underlying trends in the outcome of interest. So for example, breastfeeding rates in the US may have already been increasing before the pandemic, so that we can't attribute the entirety of the estimated effect that we see to pandemic-related policies themselves. Ideally, you'd have a control group to account for these underlying trends, but this method doesn't include a control group. So let's go back to our list of possible methods again. What about actually doing a randomized trial so that we can have a real control group and also have longitudinal data to get the best possible estimate? So one classic example of an RCT in the context of a safety net program is the moving to opportunity experiment. So MTO, as it's known, involved about 4,600 families enrolled from high poverty public housing projects across 5 US cities. The investigators here randomized the participants to one of 3 study arms. So participants could either receive a traditional Section 8 voucher, as they're known, and these vouchers allow people to move into privately owned property whose owner has agreed to participate in this government program. And these are typically housing settings in high poverty neighborhoods. The second arm received a voucher to move into privately owned property, but specifically one which was in a low poverty neighborhood. And then the third arm was the control group that continued to live in public housing, didn't get any vouchers. So indeed, here you can see that evaluations of MTO have found that it did indeed induce people to move, and the low poverty and traditional voucher groups moved about 2.7 times during the follow-up period, compared to 2.1 times in the control group. And you can also see the poverty rates in the census tract of residents also dropped for the low poverty voucher group, more so than in the traditional voucher group or the control group. And in this next set of findings, you can see that the researchers found improvements in several health outcomes among people who were randomized to the low poverty voucher group. So for example, here you see that they had reduced prevalence of obesity and reduced glycated hemoglobin, which is a marker of diabetes risk. So why don't we do RCTs like this more often? Some people tout this MTO study as the ideal way to provide rigorous evaluations of safety net policies. But one problem with MTO is that it included only 4,600 families in just 5 US cities. And 65% of the sample was actually Black, and more than 90% were single mothers. So this really makes it hard to generalize the findings to other locations or other populations. And also, a sample of 4,600 might sound big, but it's not really well powered to explore all the different kinds of heterogeneous effects that we might be interested in among different kinds of subgroups. Another key point is that MTO was very, very expensive. So it required unprecedented funding from the US Congress through the Department of Housing and Urban Development. This funding was supplemented by funding from 10 other organizations. And so fundamentally, it's just impractical to implement an RCT like this for all or even some of the policies that we might be interested in evaluating, and certainly not at a large enough scale to answer all of our research questions. So let's go back to our list of study designs again. What about examining the correlation between spending on a given policy and a given health outcome of interest? Here, our hypothesis might be that more spending is likely to result in improvements in the outcome. So here's an example. It's a little bit frivolous, but it still makes my point. And here the question being asked is, does US policy on science spending lead to increased suicides from hanging, strangulation, and suffocation? So if you just looked at this figure, you might think that that is the case, and this figure is based on real data, but your common sense tells you otherwise. And for those that haven't seen this Spurious Correlations website, it does a great job of pointing out why analyses like this one are problematic. You can imagine carrying out any number of correlational analyses, and this website does, looking at the association of some policy with some outcome and finding a correlation, even in the absence of a causal link due to the presence of spurious correlations. So here's one last example of what not to do. This is a great comic strip from back in 2011. Feel free to pause the video to read it if you'd like. And what this comic strip is doing is it's poking fun at the World Health Organization, which put out a warning at the time that cell phones may cause cancer. And they've since issued an update that cell phones are not a cancer risk. But the point is, we need evidence, and that evidence needs to guide decision-making. And decision-making often involves deciding how to spend millions or billions of dollars of government resources to intervene on some exposure like poverty or educational attainment. And we want to do better than just basic correlational studies, since we know correlation doesn't equal causation. And so the conclusion from these examples I've shown you so far is that when we examine policies, we want to use more sophisticated study designs. So that brings us to quasi-experimental designs. So let me start by sharing this causal diagram, or DAG, to illustrate the goal of quasi-experimental design, and hopefully you've gotten to see these in previous modules in this course. So here, let's say we're interested in the effects of some social factor like education in this case, and we want to know its impacts on some measure of health. And we know that education acts on health through a bunch of different mediating pathways shown here in the blue box. We also know educational attainment and health are both affected by all kinds of other observed and unobserved factors like family socioeconomic status, neighborhood characteristics, genetics, many other things. And as you've learned in previous modules, these therefore represent potential confounders. So what quasi-experimental designs do is they rely on some outside factor, in this case, variation in social policy, and this results in a natural experiment. So this policy would influence your exposure and outcomes of interest, but it would not be subject to the same confounding by these other factors. So let me define these two terms, natural experiment and quasi-experiment. They are sometimes used interchangeably, and not everyone agrees on the exact definition, but this is how I'm going to be using these terms in this lecture. So a natural experiment results from some natural variation in your exposure that is quasi-random or as good as random. That's how it's often described. So in other words, the variation is arbitrary. It's not subject to confounding by unobserved factors, even if it is not truly randomly assigned by the researcher. So this natural variation is usually brought about by some real world events or circumstances rather than being created in a lab setting. And what natural experiments do is they present the opportunity to use a quasi-experimental design. So in other words, the quasi-experimental design is an analytic method well suited to analyzing natural experiments, and it's often more sophisticated than the problematic methods we discussed a few minutes ago. So using a quasi-experimental design helps reduce the chances that your results are due to some other unmeasured characteristic of the exposed group, and so it reduces the chances of confounding. However, confounding is still possible, and we'll discuss how to think about this later in the presentation. So other than addressing this issue of correlation not guaranteeing causation, there are a few other advantages of natural experiments. One is that they tend to be cheaper than randomized trials. Here you're not recruiting, paying, and then following study subjects for some amount of time. Natural experiments are often more feasible and ethical than randomizing exposures like poverty. They also give you evidence that's more relevant to the real world because they arose in the real world rather than being manufactured in a lab. But natural experiments do have limitations. And so one of these is that they're hard to identify. There are not many exposures in the real world that are truly quasi-randomly distributed and that are going to meet the assumptions of all the quasi-experimental designs we're going to describe in the next sections. Also, while you don't have to go collect your own data, you still have to find a relevant secondary data set that captures the time period of interest and the people who are subject to your exposure of interest. And then, of course, despite your best efforts, you still might have residual confounding. Okay, so now we've gone through the motivations for quasi-experimental designs and the basic definition. In the next section, we're going to go through the most common quasi-experimental designs to get a more concrete grasp on how they can help us produce more rigorous policy evaluations.